Welcome, Kirby. Thank you, John. So as John said, my name is Kirby Turner. I'm a snowboard bum. That's what he's referring to as retirement. But I'm also chief code monkey at White Peak Software, my company that I've had for about 12 years now. One of the things I do horribly is naming things. I'm horrible at naming apps, and I did a horrible job of naming this session. Sharing knowledge about share extensions. It sounded kind of cool when I typed it up. My wife said, "Yeah, go with that." But really, I'm going to be talking about app extensions. So everything I'm talking about here, while in the second half of the talk, I'm going to use a share extension as an example, and I have demo code and a demo app and such for you to look at. Everything I'm talking about really does apply across all the different app extensions that are out there. So if you're doing an action extension, things that you're going to learn now will apply to those as well. So what is an app extension? An app extension allows you to take functionality or even content in your application and extend it beyond your application so that your users can use that functionality within another app. So I'll give an example of that in just a minute, but it basically, if you could think of it, it's like I'm in Safari, I tap the action button, and I want to do something that Safari doesn't find, that doesn't provide, such as share a link on Twitter or Facebook. That would be an example of an app extension. So what I'm going to do first is I'm going to kind of go through really quick what the user experience is with an app extension, and then we'll dive into the nitty-gritty that we as developers are most interested in. So an app extension, the way a user uses it, they first have to install your app. So an app extension is not something you can distribute independent of your app. There's no way to submit just your app extension to the App Store. Your application can actually contain more than one app extension. There are some limits. If you have a share extension, your app can only have one share extension. But if you also have actions, action extensions, you can have multiple actions and extensions in there. So an example would be, let's say you have a photo app and you have custom filters. If you want, you can set up a filter, set up an action extension for every single filter of your application. But for the users to be able to use it, the first thing they have to do is install it. Once they've installed it, they've got to turn it on. Extensions are turned off by default. Once they turn it on, then they have to interact with that extension, and they interact with it through a system-provided UI, such as the UI Activity View Controller. So what does this actually look like? Let's say that I'm in Safari, and I'm surfing the 360 IDevMin website to check out the schedule, see what's going on today. I decide I want to share this link with somebody, so I tap the action button. I go in here, and I want to select an app extension. Well, it's not there, so I have to scroll all the way over to the More button, tap it, and then I get a list of extensions that are available. So this is how the user is going to turn on that extension. In my opinion, it kind of stinks, because a lot of times, unless you tell your users that you have an app extension inside of your app, they may never know to do this. I had an app that I released last year that allowed you to share to multiple social media sites at one time, and most of the users, because I did a very poor job of letting them know that there was an app extension, most of them never used it. So you want to try to make sure your users are aware of the fact that you are providing an app extension, and you want to give them kind of instructions on how to set it up. Once they make it this far, they can turn it on, they can change the sort order and so forth, and the app extension then will finally show up inside the list here. They can tap the extension icon, and now it's loading. It's loaded the app extension, and the app extension itself is running. In this case, this is just a little sample where I'm taking the URL and the title of the website, and I'm going to just post it off to multiple websites, Flickr, Dropbox, from Facebook, whatever. So that's how the user sees app extensions. But how do we as developers see it? Well, what happens is you have a host app. The host app is the application that the user is using. That is the Safari or Photos or whatever third-party app that they might be using. It's going to send a request to your app extension. Your app extension runs as a separate process. That request is going to contain a context, and within that context is going to be all the data that the host app is going to share with the app extension. So in the case of, say, an action or share extension, when you set up a UI Activity View Controller, you're going to give it a list of activity items. Those activity items are going to get packaged up into a context, and that context is going to get sent over to the app extension via this request. How that works under the hood, the inter-process communication and so forth, is handled by the operating system. You don't have to worry about that. You just make a simple call. You present your activity view controller, it will handle issuing the request over to the app extension that the user had tapped on that screen. Likewise, when the app extension is done doing whatever job it's supposed to do, it will return a response. And that response can also contain a context of data. So if your app extension is going to modify data, it would then, in the response, send that modified data back to the host app. And the host app then can actually access that information and do whatever it needs to do. The one thing that your app extension cannot do, or the one thing it cannot talk to, is your containing app. Your containing app is kind of the third process in this little circle here. And the containing app is nothing more than a container of your app extension. There is no direct way for it to communicate with a request or a response. So what do you do in the situation where you need to share information between your containing app and your app extension? You basically add your app extension and your application to an application group. And by adding it to an application group, you now have a shared resource on the file system that you can read and write files to. You can also use this same shared resource to read and write user defaults or keychain values. So it allows you to have a readable, writable container that your application can use as well as your app extensions for sharing data. And I'll get into some neat little tricks that you can do with that for trying to notify one, have the containing app notify the app extension or vice versa. That's the only way the two can actually communicate and share data. There is one exception, that is the Today widget. The Today widget also allows you to call OpenURL, and you can pass the schema to your application. This allows the Today widget to be able to launch your application. And if you think about it, it kind of makes sense, because the way the Today widget is intended to be used, you're looking at it on your phone, you want to get more information, you want to tap on that Today widget, you want it to go into the application, and you want to be able to see something relevant about what you just tapped on in the application. So in your URL to your containing app, you're going to include additional data along the query stream. So the Today widget is the only one that is able to launch the containing app. Other than that, the app extension and the containing app, other than being able to share file storage, they really have no interaction with one another. And by the way, if you have any questions or anything like that, just raise your hand. Sure.
What's the Today widget?
The Today widget on your phone, and actually I'm really bad about not ever using it. On your phone, you can go into notifications. Like if you pull down from the top, you have, like you can be able to see this. If you pull down from the top of your phone, you'll have notifications and you'll have a Today side. The Today side, these are your Today widgets. And a Today widget would be something like, let's say you had a third-party calendar app. It could display what your next event's going to be, your next upcoming event. Kind of works similar to the complications on the watch side. It's basically little snippets of information that you're going to provide on that notification screen. So similar to doing WatchKit programming, when you want to create a new app extension for your app, you go into Xcode, you do file new target. So you're going to add a new target to your application. And it's going to give you, Xcode is going to give you templates for all the different extension points that are available on that particular platform. So just for the sake of argument here, I'll just select the share extension, and what it's going to do is it's going to generate a bit of code for me. Now all of these templates are going to generate some level of code. Your extension can have a UI, or it doesn't have to have a UI. In this case, a share extension will always have a UI, just because you want to allow the user to see what they're sharing, maybe add additional comments or something before they send that piece of information off somewhere. So in the case of a share extension, or another extension that might provide a UI, you'll get a view controller that's generated, and to make life a little easier, they'll subclass the SL Compose view controller for you. And what that does is that creates this nice little, this nice little share sheet right here. And this share sheet here, this is the SL Compose view controller. It's highly customizable. So this one I haven't customized it at all, but you can turn on and off the count indicator. You can access the preview. You can change the preview. You can add configuration items so that they actually have the ability to be able to select different things. So let's say you were sharing to a WordPress blog, and you wanted to be able to allow your users to select categories or tags. You could have those as additions here. Jumping back to where it was.
I missed what you said about creating a new project with the extension.
Is that
So
you
you're
have to create
you don't you add a new target. So
okay.
so it works just like this. So you already have. You guys see that? Good. It looks small on my screen. So you have. Well, that doesn't work. You want to come in here, add new target. You're going to do this to your existing project. And here you'll just select the app extension.
Right.
So each of the templates will generate different stuff. As I said, if you're doing an app extension that uses a UI, by default it will give you a view controller that subclasses the SL composed view controller. But you're not required to use that. You can actually throw that away and create your own view controller. It can take over the entire screen. You can do whatever you want. So you're not limited to using the system-provided view controller. In the case of this particular share extension, it's also going to create a storyboard. If you're not using a UI, of course, there won't be any storyboard. But the important piece here is this last item here. It's going to add NSExtension settings to the info P list. And the info P list that gets created, it's not the one for your application. So each time you create a new target, in this case, create a new app extension, you're going to get a new info P list for that particular target. So in here, you have your basic same information, bundle name, bundle identifiers, things like that. But at the bottom of here, these are the key pieces that you're most interested in when you're doing an extension. This last item here, this identifies the extension point. And in this case, it's actually pointing to shared services. But it could point to action services. Actions can also have a UI. So there's, I think it's called Action UI services. There's a long list of other services. There's a service for content blockers and all those other access points that are, I'm sorry, not access points, extension points that exist. So that kind of tells the system what this extension is registered to do. Above that is the main storyboard. If I didn't want to use a storyboard, I could actually say NSExtension principal class, and that would actually allow me to launch into a specific class. This would be good if I didn't want to provide a UI. So that's kind of, these two are kind of self-explanatory. It's this one here that's a little more interesting, the extension attributes. And inside the extension attributes, you have extension activation rule. The activation rule is what determines when your app extension is made available to your users. This value here, the activation rule, can either be a string or it can be a dictionary. When you use it as a dictionary, you have a set of other keys that you can actually take advantage of, and these are simple ways to kind of filter out when your extension is going to be available and when they're not going to be available. So for example, you could say you want to support files, and you give it a max count. A max count of 0 means that you're not supporting files at all. If you gave it a max count of 1, that means you're supporting a file. And so what does that mean? Let's say I'm using the Dropbox app. I've selected an app, I've tapped the little more button, or they use a little ... I tap that, I go into the activity view controller, I select my extension. My extension is going to be present because Dropbox is trying to, in its context, it's sharing a file. If I didn't support files, I had a 0 as the max count for file, I would not see my app extension. Same with images. If I want to share an image, I can put in a max count of 4. So let's say I'm sharing an image and my max count is 4. That means I'm going to allow my app extension to process up to 4 different images. If you go into the photo app and your user selects 5 different photos, well, that's more than what my max count is. My app extension now is no longer going to be available to the user under the activity view controller. So these are just rules, very basic rules for filtering when your app extension is shown and not shown. Does that make sense? So sometimes, though, you want to get more complicated. And as I said, that activation rule could also be a string. And if you use it as a string, what you're actually doing is you're using a predicate string. And so you can actually do this to build more complicated, more specific types of filters. So here's a little snippet here where I'm basically saying I'm going to support a file. So for this app extension to be made available, it's got to be a file that's selected. And in this case, I'm specifying what the file type is. It has to be a PDF. And in addition to that, the count has to equal 1. So if they select 2 PDFs, my app extension is not going to be available. But if the user selects from another app one PDF, now my app extension is going to be made available to them. So this is just, again, another way of adding more complicated rules to filter out when your extension is available and when it's not. By default, when you set up when you create your project for the first time, it's going to use a predicate for the activation rule called true predicate. And this is great for debugging because it basically means your extension is available to every single app that displays an activity view controller. So you can use any app. You don't have to worry about your filters and so forth. But you can only use that for debugging. If you try to submit to the App Store with the true predicate, you're going to get rejected. And in Xcode 7, they now even have a compile warning. So if you try to compile your app, you're going to get a warning that says, hey, better not submit this or you're going to get rejected. But it is great for debugging because now any app on your phone or in your simulator that displays an activity view controller can get to those app extensions. As I said, your app extension can have a UI or it doesn't have to have a UI. But what all the app extensions do have is they have some type of context. This context is data or information that's provided from the host application. So the host application will package up this information, again using the scenario of an activity view controller. It'll set activity items, and those activity items could be a collection of different things. It could be a URL, say 2 images, and maybe text that's been selected. You'll package that up and you'll present that as part of your activity view controller. When the user taps your extension icon, whether it's an action or a share extension or whatnot, iOS is going to gather up that information and it's going to put it into this thing called an NSExtension Context. And that is going to give you the information in your app extension that the host wants to share with you. If you have a UI, if you have a UI as part of your app extension, the view controller now has a new property called extension context. So this allows you to get access to that context. If you are not, if your extension does not have a UI, let's say that you're doing some type of action or who knows, you can create an object that actually conforms to the extension request handling. And this then will force you to implement the begin request with context. This allows the context to be sent to your application extension. At that point, then you can take the context that's been provided to you and you can save it off as a strong reference within your app extension, and it'll be available to you while you're working on the app extension or while your app extension is doing its work. The other two things with the context that you want to do is you want to be able to cancel the request or complete the request. And this is how your app extension tells or sends a response back to the host app. Once you call either one of these, the system is going to kill your app extension. So your app extension doesn't get backgrounded like in a typical iOS app. So whenever you go in, you've taken information from the host app, you've done whatever it is you're going to do with that. That could be, updating that information, posting it out to a website, saving it to your container app, whatever it is you want to do. You call complete request, and your app extension is going to die immediately after. Once that process has been complete, it's going to die. You will get a completion handler with an expired flag, and that basically tells you that there was some type of problem. It wasn't able to satisfy that request. Luckily, I have not run into scenarios where it actually happens, but it's kind of a safeguard. Most of the time, if you had something like that happen, it means that the host app kind of killed itself. Maybe it had a crash, something bad happened. And at that point, your extension is probably hosed anyway as well. So, and one other point, when you are returning data back to the host app, you can actually pass an array of items. And again, I'll show you what these items look like. They're extension items. You can pass back an array of those extension items, and that is the updated data that you want to provide back to the host application. If you don't have any information to pass back, you can return nil or just an empty array. If you look at the sample code from Apple, they always use an empty array. But on the activity view controller, in the block handler completion block with items, it says that it will accept nil as well. And again, that nil information is just the information you're sending back from your app extension to the host app. So real quick, I want to look at the code. So you have your app extension, and your app extension gives you access to your data. So at some point in time within your app extension, you want to be able to do something useful with that data. So the extension context can provide you your input items. The input items is nothing more than an array of NSExtension items. And each of those extension items has a, each of those extension items, I went one step too far. Each of those extension items has a couple little handy pieces of information. There's an attributed title, so that if there's some additional information that might be related to the content that's coming in, you can look at the title. There's another like text description. I can't remember what they are, and typically they're not that commonly used. The one property that is commonly used is attachments. So input item attachments. That's the array of the data. That's the data that you want to do something with. Now, what's happening under the hood is that you have a host app, and it's running in its own process. And you have your app extension, and it's running under its own process. And you want to be able to get the data from the host app to the extension. Now, both of these are running in their own individual sandbox. So because it's a sandbox environment, they can't just access, your extension can't just access the sandbox of the host app. So instead, these providers are made, or these providers are provided so that it can then transfer all this data from the host app process to your app extension process. And it does this using a lazy load technique. So when your extension first loads, you actually don't have the data. Instead, you get attachments from the extension, and then you can loop through each of the providers and determine what type of information is being provided to you. So here with the provider, it can say has item conforming to identifier, and you can say I'm looking for an image, or I'm looking for an URL, I'm looking for text. Then if you decide, okay, this is data that you're interested in, and keep in mind when someone sets up an activity view controller, they can put other types of data in there that you don't care about. So you only want to look for the data that you do care about. When you do find it, then you want to call load item for identifier type. And it's at this point, this is an asynchronous process, and it's at this point that the data is actually going to be moved or copied from the host app process into your process, the app extension process. So this runs asynchronously, which is great. It means it's high performing and so forth. But in your application, you have to kind of decide at what point you need to do something with that information. If you're just collecting this information, and let's say you want to post it out to a website, you may wait until almost the end of the app extension's life, so after they tap the post button. If you want to do something with that information and maybe present it on the screen, then as soon as your app extension comes to life, then you'll want to go through this process of loading that data. So really, when you go through this loop, it's really up to you and the purpose of your extension. If you look at the templates, if you generate templates of the other app extensions, you'll see that the one common thing you'll see in all the template code is they have this type of loop somewhere in there. But when you use it, when you do it, it's kind of up to you. And real quick, let's just jump over and take a look. So here is an example, and this is a sample app that I wrote. It has the container app, which is called Simple Journal. It has my share extension, and it has a framework, which I'll talk about in a few minutes. Inside of here, we have the did select post. So the did select post is what gets called when the user taps the post button. So in this case, this displays a share sheet. The user can type in something, they tap the post. So it's at this point that I want to do something with that data. So here, you can see I'm doing the loop. There's my loop there, going through and grabbing the information. This is running, again, it's asynchronously, so I need a way to gather up all that information and know that once all that information has been gathered, I can then go on to the next step. So I just took a little, because it's sample code, I took a little cheat, I just put a counter. So I use a counter as kind of my state to say, I'm going to load, one, for each loop, let's say I'm loading 5 items, the counter will go up to 5. And in each load block, I subtract my counter right here. So then I know when my counter hits 0, I'm ready to call my complete request. And if I go back and look at my complete request, all I'm doing here is what I said earlier. I'm calling on the context the complete request returning items, and in this case I'm not returning anything, so it's an empty array. So again, your implementation within this loop may vary based on what you're doing. If you're presenting a UI and you're gathering up that information to present the UI, you wouldn't necessarily need to have this little counter that I'm using. Make sense? Clear so far? So the next piece, so that's kind of like the steps or the pieces that make up an app extension. The next piece is, how do you share your code? So if you are writing an app extension, most likely you already have your containing app, you already have your core app, and you want to be able to share the code with your app extension. So it's very much like Justin was saying. There's one way that you could do this, and you can go into your source module, and you can say, I want to share this by adding it to a target. So I can add that to that target, I can add it to the share extension, so now that source module is added to those different targets. That's one way of being able to share your code, and that works fine. Another way is to use frameworks, and Justin touched on frameworks as well. Frameworks allow you to kind of consolidate that code inside of a separate target. Now, frameworks have kind of a, in my opinion, there's some pros to it and there's some cons to it. It kind of goes back to your question earlier. With the framework, they're nice in that you can actually share your code across projects and such, but the problem you run into is if you create a framework, let's say you want to distribute that framework, go with the compile framework like Justin was talking about with Google and how it doesn't actually work well with watchOS. If you create an iOS framework, what it's actually creating is called an embedded framework or a dynamic framework. This framework is actually going to get linked into your application at runtime, not at compile time. So other frameworks that we're used to using are based on static libraries, so they get linked in at compile time. The iOS frameworks are dynamic, so that means that you have to build for each target that you might potentially have to use. So if you're trying to distribute your framework then has to target the simulator and has to target iOS devices. So that means within the framework it has to have architectures for i386, x86 64, ARMS, v7, so on. Xcode doesn't do that automatically. They don't make what's called a FAT library. So you can go out and Google search and you can find scripts that will actually create a FAT library for you. And this is great. Now you have a FAT library. You have all the different architectures in your framework. Now you can distribute your framework. The problem that you're going to run into next is when you take that framework and you add it to your share extension app or your core app, is that since this is linked dynamically at runtime, there's no way to strip out those architectures. And while you're running locally, it works fine. But once you try to submit to the App Store, you're going to get rejected because you have invalid architectures. You can't submit an app to the App Store with an i386 architecture or x86 64 architecture. So you have to then go in and write scripts that'll extract out that FAT library that you made, which is another pain in the butt. But on top of all that, your app extension has an FOP list that's inside. Your framework has another FOP list, and that FOP list has a list of supported architectures. And if you don't strip that out as well, you'll get compile errors. So basically, distributing these embedded frameworks is kind of a nightmare, and they're a pain in the butt. So the most common way to use one of these frameworks inside your application is to, one, either set up a new target inside your application. So if I go back over here, you'll see that I've created, right here, I've created a simple journal kit, and that's my framework. And it's just another target within this project. Another way that you could handle this is instead of creating it as a separate target, you could create a project for your framework, and you just include the project framework as part of as a sub-project. So for example, here I have a framework in here somewhere. I shouldn't be showing code that I'm not ready to show. Right here, I have this project here. So all I've done is I've taken this project and I've added it as a sub-project to this project. So now I have access in both my share extension and my app to this framework. Now one thing you'll notice is I've said here app extension safe. There is a neat little flag when you're creating a framework that says app extension, and it says here allow app extension APIs only. When you're doing an app extension, there's certain API calls that you cannot use. For example, share app. So UI application shared app. Shared application is an object that you commonly will use inside your iOS application. That object is not available to app extensions. And again, it's because your app extension is not really an app. There's other things your app extension can't do too. It can't do like voice over IP. It can't do long-running background tasks. It can't do streaming. So there's all these different limitations. And inside the iOS SDK, there's a macro that identifies certain APIs as not being valid for extensions. So this flag, when you're creating your framework, this flag will make that check for you so that you know your framework is compatible with app extensions. But what if you want to share your app extension, your framework, with both your core app and your app extension? Well, one, you need to have this one, you want it to be app extension API friendly, right? Because you're going to use it within your app extension. But in your core app, maybe you do want to use shared application. So what you have to do now is you have to create a second project so that you'll get another build. And if you look at Apple's, Apple has a project called Lister, which is another good example of writing extensions for iOS. In this case, they actually write extensions for iOS, for Watch, and for OS X. And what you'll notice is they're using frameworks as well. So they've got this shared framework here, but they've included a framework for, here we've got a framework for iOS. Here's the shared code. There is, let's see, where is it? This is the shared code for AppKit. Here's the Watch app. Here's another one, another framework here. So frameworks, while they're great, you end up doing a lot of copying of code and such, just because of the compile problem. And it's because you have to compile targeting to a particular platform. So don't do like I did. I spent about 4 days trying to take an embedded library, an embedded framework, and make it so that I could distribute it across the board. And it's not that easy. It is doable. People that do Hockey SDK, again, but theirs is not an embedded framework. It's statically linked. But it is possible to write an SDK that can be used and distributed as the framework only. So how am I doing on time? Oh, good. All right, so sharing data. Going back to the whole idea of sharing the data. As I said, in your application, you want to set up an application group. And this application group gets added to your entitlements once you add your app and your app extension to this group. If they're both participating under this app group, and just so you know what I'm talking about when I say that, where is my simple here? If I go into my target here, under capabilities, right here, I can specify an application group. And if I don't already have one defined, I can create a new one here. What this is also going to do, Xcode is going to be nice enough to go out to the provisioning portal site, the certificates, identifiers, and provisioning, and also create this app group for you out on the provisioning site so that you can then use it in other projects. So in this case, I have, this one's using my simple journal group for that target, and my extension is doing the same thing. So now they're both a member of that app group. So turning on an app group is very easy. What it will do is it'll add it to the entitlements as well. And so this is how at runtime it knows which app groups it can talk to. Once you've done that, then you can actually share information from your extension and your containing app using keychain, using user defaults, using the file system. And because it's the file system, you can even throw your core data store out there. The only difference, though, is that when you're using these keychain and user defaults, for example, you have to specify your app group name. So if you're using user defaults, instead of saying user defaults, standard defaults, which is what a lot of which is what you do a lot of times inside of an app, instead you want to allocate and then init with suite name. Suite name is that group name. So that's that name that I set up inside of capabilities. That will then give me access to those shared user defaults. Keychain is the same thing. They have part of the API for the keychain. You pass in the group name. File system works the same way. So when you want to get your URL, instead of going directly to a local URL, you want to get container URL for security application group identifier. This is much better, I think, than sweet name, but it's not. Sweet name's a lot shorter. Anyway, you still pass in the same information. It's that group name. And so now you have a URL that's pointing to that secured location. If you put in a group name that you don't have access to, obviously you're not going to get back a valid URL. You're going to get a nil. One thing about user defaults, if you already have an existing application and you have settings that you already have inside of your standard defaults, and now you want to create an app extension and you want to share those with your app extension, you're going to have to migrate those from the standard defaults to the user defaults underneath that group name. So just be aware of that. So if you're already using user defaults and you think that they're going to be immediately available to your app extension, they are not unless you move it to that secured area. The file system, again, with the file system, yeah, that's what I thought. So with the file system, as I said, you're going to specify a URL and you're going to give it the group name so it knows that it's a secured area. And at that point, you can do anything you want with it. And as I said, you can even store your core data store out there. So if you were to set up a new core data store, sorry, I have these new glasses and I can't necessarily see. I've got progressive lenses and I have to keep doing this. It means I'm getting old. You will use the exact same code when you're setting up your core data stack. You can use the exact same code that Xcode will generate for you for accessing your store. The only difference is when you're specifying your URL for the persistent store coordinator. At this point, that's when you want to grab your secured URL. So in this case, if I drill down in here, I'm doing just as I showed in the slide. I'm calling container URL for security application group. And in this case, I'm passing in a constant. Right here's the line. I'm passing in a constant instead of a string literal. And that's going to give me that secured URL. And then back over here, I'm just now appending my SQLite data store to that URL. That's the only change you have to make to setting up your core data stack. It's the exact same as before, it's just that you now need a secured URL. So it allows you, with the file system, you can throw anything you want out there. The one thing you have to be aware of, though, by throwing it out on the file system. Oh yeah, I'm sorry.
Yeah, so this example we showed, does that mean that if in the main application, if I'm using or storing SQLite database, and a path is somewhere inside the document folder in the main application, I can use the container URL for securing this particular method to access that in a different target or in a...
Yeah, in a different application group. Right. So your application group will create think of it as creating a new shared container area on your file system that extends or goes beyond your standard sandbox. So it's kind of like a common sandbox for reading and writing data. Does that kind of answer your question?
What if you're like providing an update to the user and adding an extension, like say today's extension or some app, and they already have the app, and the main app stores that data in a document folder.
Right.
So how do you have to move?
So, so that really depends up to you and what you're doing with your extension. And so that's actually a very good question. I see where you're going with this now. So yeah, you already have your existing app, and you already have your core data store or some data store stored inside the documents directory. How do you get that information to your app extension?
Yes.
It really depends on your app extension and what your app extension needs. So in one scenario, you could migrate your entire data store, if it's an existing app, migrate it and start storing that data store in this shared container. But you don't have to. You can leave it where it is. Maybe all you're doing with your app extension is your app extension is feeding data into your containing app. And if that's the case, you could have your app extension just write some information to the file system, and then in the containing app, read in that information and input it into your core data store. So it really just kind of depends. It's just another location to store data. And depending on what you need to do, you may or may not decide that's the best place to store your core data store permanently. If it's an existing app, most likely what you're going to want to do is instead of putting the entire core data store, moving it to that new location, leave it where it is, and just export out the information and put it into a new store that's going to be in that common shared area. And that way the extension and the app can communicate with each other through that new store. You don't have to use a store either. You could actually use plist, you could use text files, you could use a UI document. So the file system will allow you to store anything that you want in there. So really it's how you want to move that data back and forth. In the case of the little sample app that I put together, I'm using the core data store, and it's taking the information that's in that shared area. And at first I was thinking I'm just going to have it stored in the core data store that runs within the main app. Because the way the little sample app works, it doesn't need to read, the extension itself doesn't need to read information from that store. So does that kind of answer the question?
Yes.
The thing that you have to be aware of, though, when you're using the file system is that while in most practical situations, your containing app is not running at the same time as your extension. Remember, your extension was launched by a host app. That means your containing app is sitting, most likely either it's been killed or it's sitting in the background. It's being backgrounded. So they're not going to have real-time communication looking at the file system. However, you do want to make sure that data is being synchronized correctly. So you want to be able to have locks and such on the file system when you're updating data, especially data that's can potentially be read by another application. And so starting with iOS 8.2, you can actually use the file coordinator. And the file coordinator will allow you to be able to lock the file temporarily so that other processes cannot look at that data. Once you're done with that, you then unlock the file. You can have a listening app, which is another process. It could be your containing app. It can now use a file presenter, and the file presenter can keep an eye on that file. And when the file changes, it will then receive a notification. Now again, your containing app is actually running in the background, so it won't receive that notification until the app is brought back into the foreground. So it's not real-time notification, but at least now your containing app knows that some data has changed. And you can use this for different little tricks. If you just want to, say, send a message over to your containing app, you could write out just a plain text file that both the containing app and the app extension are both monitoring. And when that file changes, the containing app can then react. But you don't have to use the file system to communicate back and forth. You could, if it's a very simple app, when your containing app comes back to the foreground, it could then automatically go out and look to see if any data's changed. Again, this is one of those situations where everybody's app is going to be a little different. And how they're using that containing area will determine when you need to either monitor specific files, or if you just do a general, I'm going to update every time, I'm just going to scan that entire file system and see if anything's new there. One thing to be wary of, though, even with the file coordinators, is that you're dealing with locks. And if you lock a file and your extension happens to crash, you may now block all other processes from accessing that file. And that means your containing app won't be able to get to it. And if you've coded it in a certain way, you could also block your containing app. So Apple now has a new thing it's off the NS process info object. And these things are called task assertions. And task assertions allow you to be able to safeguard yourself from these situations where you've obtained a lock on a file, but then something bad happened. I haven't actually used these task assertions yet, but if you watch and I'll have the link at the bottom at the end of the slides. If you watch the 2015 WWDC, that's too many W's. Anyway, the WWDC video for app extensions best practices. So on the list of the videos, it's pretty close to the top. About halfway through, Ian Beard talks about task assertions and provides some sample code of task assertions and such. So, so if you're writing for the file system, I highly recommend taking a look at that. A couple more things, and then we'll can have some Q&A. I said that you can have no long-running background task. An app extension, the whole purpose of an app extension is to do something quickly and then get out. So if you have a UI, you want it very seamless, but you want the user to be able to do something quickly and then exit back out. If you're doing an action, you want to process that data, return the response data as quickly as possible. You don't want to take up a lot of time. The user doesn't want to have to sit there and wait either. You're also dealing with third-party apps, these host apps and such. So you don't know what that host app is waiting on. That host app may have other events and things running on at the same time. So no long-running tasks. But there are situations where you need to upload and download data from the internet. And if that's a situation that you need to deal with, what you want to use is a background NSURL session. When you set up your NSURL session for background, not only are you going to set it up for background, but again, you're going to once again use configuration with identifier. Whoops, sorry. That's going to be the identifier for setting up the background session. Once you've set up this background session, you want to set the shared container identifier to your application group. And I apologize to anyone who's doing Swift. I still haven't made the switch yet, so I'm still all Objective-C. Anyway, you're going to give it your app group name. And the reason you're going to do this is so that your containing app, which is going to respond to the event, the handle event for background, when that process finishes, that upload or download process finishes, it needs to have access to any of the data that's being shared as a result of uploading or downloading from the internet. So be sure to set the shared container identifier if you're using background URL sessions. And that way you can have access to that data as well. And the reason that this does work, in case you don't know, a background URL session actually runs in a separate process. So again, it's one of these things where your process, your app extension, is going to get killed right away, but iOS is going to run this download or upload session as a separate process. So it will run it at a lower priority, so it may take a little bit longer than if you were doing the upload or download in your app. Real quick, a couple things on debugging. When you start to debug, you have your application will come in and say I select my share extension. It'll ask me what host app do I want to use for debugging. So this is kind of nice. So I can select the photo app, and this project will be available. I can select the photo app. I can say I want to select this photo. I'm going to share it. There's my share extension, and off it goes. And then I can set breakpoints. I can do everything you normally do within your share extension, or it's, just do normal debugging. But what you can't do is you can't debug your app and your extension at the same time. Again, these are two separate processes. So what do you do if you want to test something that your app extension is doing, but you need to handle, you want to see how your container app is handling it. So for example, you want to see that the containing app is receiving notifications that something has changed on the file system, or you're doing a background upload and you or download of information. You want to make sure your containing app is handling the retrieval of that information when that session finishes. You can use NSLog statements, but again, the problem with NSLog statements is that your app extension is running in a separate process. So in Xcode, in the output window, in the console window, you're not going to see the NSLog statements from your app extension. So the way I get around that is there's a little free app from Lemonjar called iOS Console. And iOS Console gives you a dump of the system console. This is also a very handy tool for just debugging other problems. It won't work with the simulator, but it will work with your device. And you can use this now. You test your, you debug your containing app on your phone, and then from your phone you go into another app to launch your app extension, and now you, through iOS Console, you'll be able to see all those log statements that come in from the from your console, come in from your app extension. Let's see. I've got to wrap it up here. So a couple things that I realized that I forgot to mention, and then we'll do the Q&A. Your app extension must always be a universal target. You cannot target just iPhone or just iPad. And the reason is because your app may be installed on different devices. So if your app, your container app, targets iPhone only, there's nothing to stop an iPad user from downloading and installing your app. Now your app on the iPad is going to run in compatibility mode. It's going to run as if it's kind of like an iPhone app. But that app extension can be available to other apps that are on the iPad. So your app extension has to be universal. If it's not, you will get rejected. So that's one thing I want to mention. The other thing that I forgot to mention when I was talking about the context information is when you're parsing through the data. Where is it? Oh, I won't bother looking for the source code unless someone really wants to see it. When you're parsing through that context data, and that was the piece where I said earlier, you're going through and you're doing the load items and so on to get that data. Oh, here's a good example. So I'm going through my context. My provider's loading an image, because I'm looking for an image. So I want to add, in this case, I'm adding the image to my model. See if I have that code. So right here. Now, this is the tricky thing when you're dealing with app extensions. You're not only working with host apps that are provided by Apple. You're working with host apps that are provided by third parties. And let's say, for example, like an image. If you use the photo app is always going to send you a URL, a file URL to that image. And then you can load it, which is great. It works simple. A third-party app, on the other hand, may not provide a URL. And in most cases, it's not going to provide a URL because it would have to be a URL to its sandbox data. The only so the only exception would be if it were trying to share a photo that it retrieved from the asset library. So if it's sharing from the asset library, then it could share a URL. But if it's a photo or an image that it contains inside of its own sandbox, you're not going to get a URL. Instead, you're going to get an NS data. So even if you are testing on a simulator or on your device and you're using Apple apps to test with third-party apps, because you will be surprised at what type of data they send you. And it's not necessarily the same thing that you're going to see from Apple. So in this case, what I'm doing is I check to see what the class type is. So this is coming in from that load, and I check to see if it's a URL, then great. It's a URL, so I'm then going to load the data off the file system. And if it's not a URL, I'm going to check to see if it's data. And in this case, it's raw data to this image. So that's something you want to be aware of when you're testing. It's always test your app with third-party apps as well. Especially if there's certain key third-party apps that you find that most of your users are going to use, definitely test your extensions with those apps. And that's it. So here are the resources. I'm sure John's going to share the slides and stuff. If you're really doing a lot with app extensions, read through the programming guide. This is the video that I mentioned. Well worth watching, especially if you're doing anything with the file system. Tom Harrington, he also wrote last fall a couple of blog posts about app extensions. So that's definitely a good read. This is the URL to his category, so you'll get all of his articles. And of course, if you have any questions and such, I'm available on Twitter at KirbyT, and that's my email address, Kirby@WhitePeak And with that, thank you, and I'll open up to questions. That's my home, by the way. No questions? Oh.
So I want to put this in context. I've heard that there are image processing apps that allow this, but I would imagine they would implement it as an extension. So I'm going to take a picture. I'm going to give this to filtering app,
Right.
and then I actually want to get that filtering app, that image back.
Mm-hmm.
And so you mentioned some of the file system watchers and that sort of thing, but I didn't quite follow. How does it actually come back to?
So in that case, you're sending the data back to the host app, right? So the host app is going to send, in its context, it's going to send the image data to your extension. And let's say your extension is to apply a filter. It will then update that photo, it'll apply the filter, and it will create a new context. And in the new context, it's going to send that context back to the host app. So in that case, it's not using the file system at all. And so where that happens, again, this is that whole bifocal thing. I'm new to these classes, by the way, and everything looks blurry. It's right here. So when you say complete request returning items, that's in that array that you're passing. You're actually going to create an array of extension items. So the same thing that we parsed out to get the data, you're going to recreate those same things with the new data. So you're going to take your data, your new NS data, which is the photo that has the filter applied to it. You're then going to wrap that inside of an extension item, and you're going to pass it back in the array. On the receiving side, the host app has used the NS Activity View Controller to display this. The UI Activity View Controller has two completion handlers. There's one, these are properties on the UI activity view controller. One's just called completion handler. The other's completion handler with items. And so it's with items, you would provide a block to that property, and that will give you your items back. So now once the host app receives that, once that block executes in the host app, you can do whatever you want in your host app with that data, which would most likely be to redisplay the photos. So that's it. Thank you.